Hello, in this video I'm going to solve the following problem for you. This is a problem on the topic of power roots. Let us read the problem first. Let A and B be real numbers such that A is greater than 1 and B is not equal to 0. If A times B is equal to A to the B and A over B equals to A to the 3B, what is the exact value of B to the minus A? That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the calculations correctly, the answer will be 16. The interested student can refer to the following playlist for more problems of this type. The link of the PDF file that you see on the display now is in the description below the video. Okay, now let us solve the problem. So here you see that I have two unknowns. One of them is A, one of them is B. Of course, I have some information regarding A and B. I know that A should be greater than 1, B is not equal to 0. Okay, so if I want to look at the problem, this is a system consisting of two equations and two unknowns, okay? So one idea is to be able to calculate A and B individually. And when we found A and B, we put them here, and then we calculate this question mark. Okay, but how can I do that? So if I want to solve a system of two equations in two unknowns, I have to do something so that one of the variables is eliminated, so that I get only one equation in one unknown, so that I can solve it and find that unknown and put it back into one of the equations, of course the simpler one the better, and then find the other variable. So I would say that it is not hard to see that here, if I multiply these two equalities side by side, that would be a good idea. Yes, because at least this B and that B are cancelled. Of course, this is not a very standard problem, so you have to also be smart to find the wise way to do it. But let us, for example, do this. First of all, this is a valid way of doing it because if two numbers are equal, it is clear that if I multiply the left-hand sides and I multiply the right-hand sides, I can still keep the equality sign. Yeah, so I will do that. So I will take AB from this one and multiply it by A over B, and then equal A to the B multiplied by A to the 3B. What was the motivation of doing this? Because I immediately realized that when I multiply AB by A over B, at least B is eliminated from the left-hand side. Okay, so this B here and that B there are cancelled, then A will be multiplied by A, it gives me A squared. And here I have two powers with the same bases. I want to multiply them, so the rule is to write the same base and add the exponents. Okay, of course, B plus 3B simply becomes 4B, so I have to write 4B. And now look, I have a power, second power of A is supposed to be equal to 4B. The power is 4B of A. The bases are the same, and it is mentioned in the problem that A is greater than 1. Because if A is 1, I cannot conclude anything about the exponents. If A is 1, the left-hand side becomes 1, the right-hand side becomes 1, independent of any choice, independent of my choice for B. So because A is greater than 1, and this power of A is supposed to be equal to this power of A, this can happen only if the exponents are also equal. So this means that 4B, which is exponent of A on the right-hand side, should be equal to 2, which is the exponent of this power on the left. And then immediately, if I ask you what B is, you divide everything by 2, so it becomes 2 over 4, or simply B is equal to 1/2. Okay? So at least one of the unknowns is determined. Okay, so what we can do, now that I have now that I have B, I can put it back into one of these equations, then there will be only one unknown left for me, and that is A. I would prefer to put it here. It seems for me simpler. So I will take my B here and put it there. So it becomes what? A every b will be replaced by 1/2. So this becomes multiplied by 1/2. And on the right-hand side, I will have a to power 1/2. Okay, so what I can do, so let me first multiply by 2 to get rid of this fraction. So the left-hand side becomes simply a, the right-hand side becomes 2a to the power of 1/2. Now, working with fraction powers or exponents is not that easy. So let us just get rid of it. How should I get rid of this fraction power? I have to raise the left-hand side and right-hand side to an appropriate power so that I can get rid of this 1/2. And I want to do it in an efficient way, so I don't want to increase it too much. I want to do it as in a sufficient way. So what do I mean by that? If this number is supposed to be equal to that number, I actually raise the left-hand side to power 2, and I also raise the right-hand side to power 2, okay? So now what happens? I copy and paste the left-hand side here, which is a squared, but here I have a product, and the product is supposed to raise to power 2. So this means this number will be raised to power 2, and that other number will be raised to power 2, yes? But this is simple, so this is a squared is equal to 4. But then we have a rule of powers that if I have a to power m to power n, it becomes a to power m times n. So a to power 1/2 to the power of 2 is just simply a to the power of 1/2 times 2, which is a to power, this becomes 1, and a to power 1 is just simply a. So the right-hand side becomes 4a. Okay? And now it is mentioned that a is greater than 1, so it means that a is not 0. So if two numbers are equal, I am allowed to divide the left-hand side and the right-hand side by the same number if I am sure that that number is not 0. I want to divide the left-hand side by a. I want to, of course, I have to divide the right-hand side by a as well if I want to keep the equality sign. Am I allowed to do that? Yes, I am allowed, because a is greater than 1, so automatically I know that a is not equal to 0. And then what is the benefit of that? You see what happens. One of these a's and this a are cancelled, so the left-hand side gives me just simply a. And on the right-hand side, a's are cancelled, and I just get 4. Okay? So you see, I am using this assumption both here and there. So that assumption is necessary. But why this assumption is given, and that is clear, because b in the first place appears in the denominator of one of these fractions, so it cannot be equal to 0. So if the question is supposed to be designed in a proper way, they have to give you the conditions that are necessary. Okay, now that is very easy. I know what b is. Now I know what a is. So I need to answer the question mark. So the question mark is equal to b, which is 1/2, to the power of minus a. A is 4, so minus a is 4. And then during the lesson, I told you that if you have a fraction, you can flip the numerator and denominator, and that the price that you pay is to just get rid of that minus sign. So this becomes 2 over 1 to the power of 4, but that is nothing except 2 to power 4, and 2 to power 4 means 2 times itself 4 times, and the answer, as is supposed to be, becomes 16. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.